Good morning. This is a video to help you fill out your study guide for your Unit 2 Quest. The first page of the handout you received in class on Monday looks like this, and the study guide starts on the second page. Okay, so to begin with inputs and outputs, inputs are x values. And outputs are y values. Another important thing to put here is function notation. So if we have something like f of x equals y, the x inside the parentheses represents our input, and whatever comes out on the other side is our output. So for the example, I want to show two types of problems. We talked about two main categories of problems with inputs and outputs. One is given input, find output, and the other is given output, find input. So for both of these, we'll use the same equation. Let's use f of x equals x squared. So with given input, find output, we'd be asked something like, okay, you have this equation f of x equals x squared, now evaluate f of 3. So we'd say, okay, whatever's in the parentheses is our input. That is what we're going to plug in for x into our equation. So f of 3 would be, sorry, not x squared, 3 squared, plugging in 3 for x, and then 3 squared is 9. So our final output, our final answer would be 9. Okay. Next, given output, find input, we'd be told something like, if f of x equals 16, find x. So the opposite thing is happening. Instead of being given the input and finding the output, we're given the final output and we're going to go backwards to find the input. So what I'm going to do is use the same equation up here, but instead of plugging in 16 for x, I'm going to plug in 16 for f of x on the other side of the equation. So I'm going to get 16 equals x squared, and then I'm going to solve for x. So taking the square root of both sides, I get x equals positive 4 or negative 4. Square root always has two answers, a positive and a negative. Okay, moving on, range. We really just talked about range graphically, and a range is all possible output values. And we know output values from our other vocabulary definition are y values. So all possible y values. Range, we normally would find it using a graph. So if I had something like this, my y values are between 4 and 6. And then my function looks something like, starts here and ends here. The x values are 2 and 7. For range, what I care about is the possible y values that this function exists between. So, I didn't draw this very well. But let's say that this function exists between the y values of 4 and 6, meaning the lowest y value, the lowest value on the y-axis is 4, the highest value on the y-axis is 6. And the way we'd write that is y is between 4 and 6. Okay, so range has to do with possible y values. Domain is the opposite. All possible input or x values. Okay, so domain, let's use the same exact graph. I'm not going to redraw it. but the domain of this same graph would be x values are between 2 and 7. So for domain, we'd be looking horizontally along the input axis or the x-axis. I should have labeled x and y. So all possible x values, the lowest possible x value is 2, the highest possible x value is 7. There's more good practice problems with these graphs, and if you remember the handout, I believe it's 2.2, and it has the example of Mr. Lieberneck biking to work, and we go over this graphically, as well as the sunflower problem. All right, moving on, horizontal shift and vertical shift. Horizontal shift, maybe a good just visual reminder, horizontal means side to side like this, vertical means up and down. So horizontal, something moves either left or right, vertical, something either moves up or down. Horizontal shift in an equation would look like x minus h. We'd say that this is an inside change. Therefore, it is going to change the inputs, affects inputs, and it results in a horizontal shift. Okay, so for example, if you were given something like you're given a function like f of x equals log of x plus 2, you'd say, okay, that is an inside change. So I know it's going to impact the inputs. It's going to result in a horizontal shift. And I'm going to say, okay, because it's a positive 2, there's a negative here. So I know it looks like a positive 2, but it's actually a negative 2 because the negatives canceled out. So that means it's going to shift left by 2 units. So it's the graph, it's the log function, but it's shifted left by 2 units. That's the important transformation because we have a 2 inside the parentheses. Okay, let's move on to vertical. Vertical would be like f of x plus k. This is an outside change. It's outside the parentheses. Therefore, it's going to affect the outputs of the function. Outputs are y values, therefore it's going to result in a vertical shift. Okay, so same idea over here with the example. If we had f of x equals log x close parentheses plus 2, so the only difference here, inside or outside parentheses, actually changes a lot. This is going to be an outside change, so it's going to impact the outputs, and it's going to result in a function that shifts up by 2 units. Okay, so on this quest, you won't have to graph any transformations. What you will have to be able to do is identify what the transformation is. So you'll need to know that inside changes result in horizontal shifts, and outside changes result in vertical shifts. Okay, so once you have all these vocab words, these are the important ones that show up on the quest. Make flashcards if that's something that works for you in studying. And if you need physical flashcards, I have some I can lend you if that works better for you. Okay, moving on to some key concepts. The first key concept is evaluating functions with function notation. And the problem we're going to solve is if I gave you this function, I could ask you to evaluate something a little bit more complicated, such as f of x minus 3. Okay, so what do we do if we have an expression inside the parentheses instead of just a value? So now instead of x, we have x minus 3. Well, the same idea applies. Whatever's inside the parentheses is my input, so that's what I'm going to plug in for every single x value that I see in this equation, which I have 2 of them. So I'm going to rewrite this equation, but I'm going to replace every single x with this expression, x minus 3. So 4 times x minus 3 squared plus 5 times x minus 3 minus 7. And now to simplify, to get all the way to my output, I'm going to just keep in mind some algebra things. So the first is that this x minus 3 squared, I have to expand it into the product of 2 binomials. X minus 3 times x minus 3. I have to distribute this 5x minus 15, minus 7 stays the same. Okay, now I'm not going to distribute this coefficient of 4 until I fully distribute out this the product of 2 binomials. So this is going to be x squared minus 3x is minus 6x, and then negative 3 times negative 3 is positive 9. All of that is going to be multiplied by 4 plus 5x, and then I can combine my like terms here. Negative 15 minus 7 is negative 22, I believe. Okay, now to distribute this coefficient here, this 4, 4x squared. 4 times 6 is 24x, and 4 times 9 is 36. Okay, I'm almost done. I'm just going to combine like terms. So negative 24 plus 5 is going to be negative 19x. Sometimes it helps to like circle the common terms, the like terms, so you know what you're going to combine. Okay, so I combined the negative 24 and the positive 5 to negative 19x, and then 36 minus 22 is, and that is actually my final answer. That is my output. So one good thing to keep in mind that I should have mentioned at the beginning is I automatically went in to plugging in my input into the equation to getting my output. The way I knew how to do that was because anytime that you're told to evaluate a function, this is from 2.1 in your textbook, evaluating a function means given input value, find corresponding output. So if you're like seeing a problem that says evaluate and you're like, what does it mean to evaluate? A good thing to remember is the definition of evaluate. It means that you're given an input, you're given a function, and then you evaluate the function to find the corresponding output for that input. Okay, number 2. This is one of the trickiest things on the test, finding the domain algebraically. So the first example I want to do, we're going to kind of split into 2 categories of problems. One category is finding the domain of a function that involves a fraction, and one is finding the domain of a function that involves a square root. So an example of a fraction could be like if I said find domain of 1 over x minus 3. And sorry, it's a function, so it should be f of x equals 1 over x minus 3. So in this case, what I'm going to do is set denominator equal to 0. So I'm only care about the denominator of this function, which is x minus 3. I'm going to take that x minus 3 and set it equal to 0. And then my second step is to solve for x. Okay, so to solve for x, x minus 3 equals 0. I'm going to add 3 to each side, and I get x equals 3. And then my answer is going to be all real numbers except for 3. Why does this make sense? So if I were to take 3 and I were to plug it into my function as an input, I would get 1 over 3 minus 3, which is 1 over 0. In math, you cannot divide by 0, so the function would be undefined at that point. So another way to think of this is function is undefined. When x equals 3, because the denominator would be equal to 0, which we can't have that be in math. Okay, next example, and then I'm going to stop the study guide here and make a part 2 for the last key concept. So this one, the example would be, you might be asked to find the domain of something like the square root of, let's do x plus 5. So in this case, oh sorry, can't see. In this case, your first step would be to set everything under the radical, under the square root, greater than 0. This is because you cannot take the square root of a negative number, so we know that this expression underneath the square root must be positive. It must be greater than 0 because it is impossible in math to take the square root of a negative number. That would be an imaginary number. Okay, so we're going to take this x plus 5, we're going to make it greater than 0, and then same second step is we're going to solve for x. Okay, so I have x plus 5 is greater than 0, subtract 5 from both sides, and I get x is greater than negative 5. So here my final answer would be the domain is all x values greater than negative 5. So as long as this number is greater than negative 5, it makes sense. The function is defined. All right. I'm going to pause the study guide here. Stay tuned for part 2, where I will go over key concept number 3 and number 4. All right. Happy studying. Let me know if you have any questions. Have a great rest of your day.